all fixed, I guess it's time to start. And as usual, we have lots to discuss. For our top news, the destruction of the world's forests increased sharply in 2020. In technology, we've changed this, but we have a study that shows there's a promise of quantum computing using factory-made silicon chips. It shows an awful lot of promise for doing things. Materials. If you have 2D materials and you combine them, they get a voltage. And might that lead, Richard asks, to more efficient solar panels? In astronomy and physics, new studies are showing doubt about the composition of 70% of our universe. The question is, isn't it beyond belief that we still don't know what most of the matter in the universe is, what it's made of? We can't find it. Environment, we're now turning wood into plastic. In biology, sleeping octopuses may have dreams, perhaps dreams. But if sleeping octopuses may have dreams, that means they're somewhat similar to humans and other mammals, despite being separated by more than 500 million years of evolution. For us humans, apparently, and I don't know who this applies to here, people with more wisdom have a more diverse microbiome. People who are lonely don't have a diverse microbiome. We don't know which came first, the microbiome changes or the mental changes. We might speculate. In health, the vaccine apparently can stop brain tumor growth in humans. So we have a vaccine to stop brain tumor growth. Can we now stop the progression of cancer? So, Richard, what's this about the top story that the destruction of the world's forests increased sharply in 2020?
Well, as you know, I like to start off with a positive story, and this is a long way away from a positive story. Uh, we still are having trouble taking care of our planet. And last year, the rate at which the world's forests are being destroyed increased sharply. And at least 42,000 square kilometers of tree cover were lost in the tropical forests. This loss is well above the average for the last 20 years. The losses were particularly severe in humid tropical primary forests like the Amazon, the Congo, and Southwest Asia. These environments, besides being great carbon sinks, also have irreplaceable ecosystems and diversity. Uh, the emissions increase we have from last year's tree loss is equivalent to the emissions of about 600,000 automobiles. Just to scale it, that's how much forest we lost last year. It turns out Brazil, under the leadership, if you can call it, of Bolsonaro, is the country that lost the most of its forests last year. And there is concern about the next few years because the pandemic has caused immense amounts of financial damage around the world, and there is a fear that some of these countries, to be able to help them recover their economy, will end up doing more to sell off and develop their forests. And so that's what we have. There are other reasons, by the way, that the forests are being reduced. In the case of Germany, the increase in forest loss tripled over the losses of just 2018 because of the damage from bark beetles, which was caused by the increased temperature. So here is a case where environmental changes make the forest health worse. It also turns out Australia, you've heard of Australia, they've had a ninefold increase in tree cover loss in the past 2 years, mainly because of extreme weather and forest fires. So already we can see part of our environmental issue uh, decreasing the planet's ability to respond. And the world's forests are still an enormous carbon sink. And we need to keep that carbon sequestered to avoid catastrophe and climate change.
So, any thoughts?
The deforestation in Brazil, a lot is being cut to make room for cattle ranching, which of course affects the environment too. So it's a double-edged problem.
Yes.
Nowhere in the article did they talk about population, and really the issue isn't anything except excessive population competing for scarce resources.
Well, I'm not sure, but I believe that the cattle ranches in Brazil sprung up because of demand for red meat. And so it seems to me that if the richer nations were to plunk a very high tariff on it, it might sort of take enthusiasm away for sacrificing our forests.
Here in Mexico, the cartels are getting interested in lumber. That's part of their business now. They're diversifying. I don't know if you remember, about a year ago, maybe less, the environmentalists and head of a wonderful butterfly sanctuary in Michoacan, where the monarchs go, had death threats and so on, and they finally killed him because he refused to back down. He was going to protect those trees. And then the second in command was executed as well. So many reasons.
Mm-hmm.
Yeah. A couple of weeks ago, I watched a presentation by a professor of forestry from Vancouver Island University. And, there was a hell of a lot of data. The thing that stuck in my mind is that pine beetle, the same trouble as they're having in Germany, it's a problem in British Columbia. You need like 2 or 3 days of -30 temperature to kill the beetle, and we're not getting that now. And so it's a real, it's a problem that they recognize. I'd just like to see how British Columbia stacks up against other jurisdictions, because according to this professor a couple of weeks ago, there is an awful lot that's being done. They're planting different species. They're planting 2 trees for everyone they cut down. There's a lot of effort.
I would say in Indonesia and Borneo, and of course Malaysia and Philippines as well, they're destroying virgin natural tropical rainforest to build palm plantations to raise money as a commercial crop.
Yes,
Although palm trees do probably help a little bit with the carbon mitigation, it's nowhere compared to a lush tropical rainforest.
Now, in Malaysia and Indonesia, those are both places where actually they're making a little headway about restoring forests. So those are places where it's not as bad as it was. Malaysia has lost about a third of its primary forests in the last 50 years, but has also recently started reducing deforestation basically with tougher laws on logging and things like that. So again, some of these places they are trying and some of the efforts are successful. It's just we're not trying enough in enough places.
Yeah, but I think, like Andrew said, the real problem is I'm not sure the planet can sustain 8, 9, 10 billion people at the standards of living everybody is aspiring to. That's the real crux of the problem.
Well, we need a
You have,
better pandemic then, I guess.
That might be Mother Nature's answer to the whole problem. Who knows, right?
But we need a pandemic that kills all the young people because they're the ones that reproduce.
Well, Richard, um, you're talking in the technology story about quantum computing, and we've often talked about that as being something that could really make things so much more efficient. Apparently, factory-made silicon chips show the promise of doing just that. What's that about?
Well, this to me is one of the most exciting technical stories that I've heard in a while, certainly on the computer front. And what they have done, we have been hearing now for a long time about the promise of quantum computing. And the promise is that it looks like from quantum computing, we can do things, solve problems that we never could before with any other kind of computing. So it's a whole step forward in those capability. The problem with this quantum stuff, though, is it's all this funny subatomic behavior and once you figured out how to do it, then you have to build the quantum chips that would be able to execute this. And they have been thinking that existing technologies, semiconductor technologies, were not going to be able to do the job. And so it means then to realize the promise of quantum computing, all we would need to do is to develop some new microelectronics technology, maybe using new elements that we've been hearing about over the last few years to create this next generation of chips. And uh, as someone who used to be in the business would know, to create a new kind of technology and deploy it and get to be where you're making things is a long job. And so, what they were able to do is to find out that they could make chips using conventional CMOS technology and have them be able to make qubits. Qubit is the quantum computing like a bit is to regular computing. And if you can make qubits, then you can, they think, make the whole thing. Next, you have to make a bunch of qubits and have them working together, is basically where you go from that. And they can now make qubits using CMOS technology. CMOS technology has been around for more than 50 years, and the scientists who are involved in this say, quote, it has taken 70 years for transistor development to reach where we are today in computing, and we can't spend another 70 years trying to invent new manufacturing processes to build quantum computers. Well, now it looks like we don't have to wait for this, and uh, these quantum computers will show up a lot faster than anybody thought of. You're still not going to have the quantum computer on your desktop, though. The chips that they made and tested out this time, before they could turn them on, they had to cool them to a fraction of a degree above absolute zero. And so I don't think you're going to have that kind of cooling system on your desktop. And so this is the kind of thing that you will see deployed in the biggest and most powerful systems. This particularly is good for things like AI and problems where you're dealing with many variables like life and biology and the environment on the planet. So with these kind of computing tools, it'll give us another way to be able to look at the hardest problems that we're facing in the world today.
Any thoughts?
What I sometimes wonder is, we see, we're trying to get smaller and smaller computers, smaller and smaller chips. I mean, it wouldn't matter if the computer was as big as a house, if it would do the same job. But I don't understand why it's not. Is it not just a question of scale? Is it something else,
Well, one part of it is efficiency. Right now, the video files that people are watching from YouTube and other sources, combined with other stuff we have on on our computers around the world, uses about 10% of the energy generated on the planet. That's more than we're talking about with the loss of the forest last year. And so it's a incredibly big number. That, by the way, is doubling every 2 or 3 years. So the future of it, if this computing stuff and communication things continue to be such a key tool in our life, it is going to take more power than the planet has just to be able to keep it running. So that's one of the issues.
Well, Richard, if we move on to materials, you're saying that if two-dimensional materials combine, you could get a voltage out of it, which might be possible for all kinds of things, maybe more efficient solar panels. What's that story?
Well, with 2D materials, it still to me is an exciting time because they are making what seem like fundamental discoveries every week. And, that's not typical in science, though, discoveries happen all the time. What they have found here is now the researchers have found a new way to develop photoelectric capability. And what they have found is using two different materials that have different crystalline structures, tungsten selenide and black phosphorus, that overlaying one over the other and getting it in just the right position, then it generates a voltage when exposed to light. So it shows photovoltaic property. And they believe even just this combination, they will be able to make solar cells that are more efficient than the present technology where you make them out of silicon. And they still have much fundamental work to do here. One of them is you've heard about the uh, graphene with a twist where you have two layers and they're twisted at 1.1 degrees and suddenly get magic properties of superconducting. Well, they haven't tried that yet with these two materials, and so they're exciting to see what they're going to find out next. And then there are many other materials that form crystalline structures that you can make in 2D material, and they're nowhere near looking at all of those different things. So, again, what happens with these 2D materials with crystalline structures is the atoms are made in a pattern depending upon the crystalline structure. And because the atoms have this fairly fixed position, then their electrons have a fixed position. And when you superimpose one set over to another set, you get relationships between the two of them that you have never seen before. And sometimes they do cool stuff, like be able to generate electricity. This, of course, is an immensely far away from anything that can be in production. Not only if you were going to try to make solar cells from this, not only would you have to be able to make large quantities of both materials and get them precisely positioned, you'd also have to make sure that they could last for 10 years, for example, under the sunlight. So it takes a long time for discoveries like this to work it through and become things that affect our lives. But new developments in material science are things that push the capabilities we have in the world. And this is this week's amazing discovery about 2D materials.
Any thought?
Yes, I think that the being able to improve on solar cells, in addition to making it easier to power your house and its needs, also electrical vehicles. Hyundai have a model now where they have put solar cells on the roof of the car, not to power it completely, but to assist in
Right.
the battery. So I can see future benefits of that being quite important.
Yes, one of the things they're doing a new plan for solar cell development is to put them on water sources like canals. If you put solar cells on canals, it improves the efficiency of the solar cells and reduces the evaporation of water. So there are things that we're learning to do that can get us to new degrees of efficiency using the stuff we now know how to make.
Who is doing this kind of research? Do you know?
All over the world.
Yeah, well, that's very vague.
Well, actually, I do know that some rivers in India, the canals have been covered by solar panels.
Yes.
That happened about maybe 4 or 5 years ago.
Yes, India is one of the places they talk about that. California is another place where there are a lot of canals. India needs solar power worse than California.
Well, Richard, moving on from materials to astronomy. In materials, we're getting to know more and more about things. But apparently in astronomy, we have no idea about 70% of our universe. What's this about that?
Well, the first part about it is uh, take our universe, for example, go out at night and look around and look at all the stars you can see and look at the Milky Way and maybe get binoculars and look at it more and maybe get a big telescope and look more. Uh, all that you can see of the universe is only about 5% of the matter that we know that is must be there or we think must be there. And uh, that's not very much. Now, we know that there is more matter than we can see because we can see the gravitational effects of this matter on things like the motion of galaxies and things like black holes. So we can tell that something's got to be there to account for the gravity. We think that what they call dark matter, which are slow moving particles, we think, because we haven't found any of them either, we think dark matter is about 20% of the universe. And so we have visible matter as 5% and dark matter as 25%. And then all we have is the other 70% to figure out what's this stuff. And the reason we need to find this other stuff is that the universe continues to expand. And if the universe were dominated by all this gravity, then it would all collapse back together. But instead of collapsing back together, we have found that the universe is expanding and it's expanding faster all the time. And so you can't explain this with gravity. And they tried to use the idea of dark energy to explain it. And of course, because it's dark, what that means is that's the stuff you can't find anywhere. So our leading theory about what this other stuff was is it's some other kind of thing that we can't find or detect. And that's most of the stuff in the universe. Anyway, it may surprise you, but this has been a controversial idea in science for a while. And the problem with it is they have not been able to find any other explanations that were even suitable to try to explain what we can see out there. And they feel like whatever the theory they have the actual kind of universe to check it against to see if the theory is any good. Anyway, there is a group of scientists now who have tried a different kind of simulation. They have taken everything we know about the universe and put it in this giant computer simulation, except instead of putting dark energy in the computation, they uh, kind of tweaked their definition of dark matter and gave dark matter a kind of gravity. And so they didn't have any of the dark energy. And when they ran their simulations this way, the universe works out just the same as it does with the idea of dark energy. So now they're saying there may be some other explanation yet something else that we don't know about what we think is most of the universe that explains it. And they say, quote, honestly, our discovery may just be a coincidence, but if it isn't, it's truly incredible. It would change our understanding of the universe's composition and why it is expanding. As far as our current knowledge, our ideas about dark matter with a type of magnetic force and the ideas of dark energy are both equally wild. And so we may exchange one wild idea for another one, and that will should make you sleep better at night because now we know what the universe is.
So, any thoughts?
Only thought is it makes my head spin.
Yes, I know.
Yeah.
Mine too.
What it really points out, though, is that these unknowns are really just the unknowns that are necessary to make these mathematical models balance.
Right.
And you could
Yes.
use matter, you could use force, you could use energy. And these guys have just looked at a different thing to make the equations balance.
Right. It goes back to Einstein with his cosmological constant that he theorized in 1917. And he theorized that at the time because he couldn't make the equations balance. And so they're still trying to find out something that would explain Einstein's ideas of 100 years ago. And they're still looking. When I was dealing in the semiconductor company, sometimes I dealt with financial statements and things like this, and I learned about a number that sometimes I would hear about, which is called uh, WITB, WITTB was the number, and that's what it takes to balance. And so they're looking for the cosmological constant whatever.
Well, Richard, if we move on to environment, why would you want to turn wood into plastic? And what's the implication?
Well, the why you'd want to do something like this is that one of the most severe parts of our pollution issue is all this stinking plastic that we make and seems to accumulate in the world, particularly in the oceans. And so the oceans have become the world's plastic garbage dump. And so they're looking for alternatives. They have had some other uh, approaches to try to make renewable and biodegradable plastic. And before it's been tricky with production processes that needed toxic materials and that are expensive. And the stuff you make from it isn't really strong enough to be able to replace most of the plastic. But now they have made a breakthrough using wood byproducts that shows promise for producing more durable and sustainable bioplastics. And this is plastic that is either uh, biodegradable. If you just put it out in nature, it will degrade naturally, or it can be recycled. It's actually made from a uh, taking wood dust and applying some material to it and making a slurry, which is kind of a thick, wet thing. And you can take this slurry and then mold it using conventional plastic techniques or form it, like put it through rollers and things. And again, make a good quality plastic that is biodegradable and recyclable. And what they're talking about this, for example, one of the uses that they think this would be very appropriate for is uh, the plastic, like in the plastic bags you get at the supermarket, or the plastic wrap you use to wrap food. So you can use sheets of it like this, or you can mold it and make other kind of plastic items. And so the problem with this is, if this is really successful, then they have to look next at what does this do to the environment. You're growing lots of trees, so that's good. You're taking carbon out of the atmosphere there, but then you're cutting down the trees and grinding them into dust and making them into plastic. What does that do to the environment? So they have more questions to answer before this can be a real thing. But this is something that is very promising as a biodegradable and recyclable alternative to plastic instead of oil.
Any thoughts?
As long as they balance cutting down trees with planting new trees, that would be okay.
And like somebody said, we have to plant more trees than we cut down.
Even better.
And you're going to use the Amazon forest to do this?
I don't know if those are the right kind of trees, but we need to do something.
Anything else? Okay, then moving on to biology. Apparently, octopuses have dreams, and they examine them, and what they see about them is somewhat similar to us and other mammals. Despite octopuses were separated by more than 500 million years of evolution from us. What's this about?
Now, octopuses are a form of mollusk, like clams and things like this. They obviously don't have a hard shell, but that's how far away they are from us biologically. And uh, it's one of the things that's interesting about octopi is they, like us, have big brains, and they're what they see is during they see octopuses, like humans, have two phases of sleep. They have periods of deep sleep and periods where they're more active, comparable to our REM sleep, which is our dreaming sleep. And when they're in the active periods of sleep, you can tell, the scientists can tell, because instead of their bodies being inert, then the body's skin color changes and their bodies twitch and their tentacles and suction cups twist, and they look like they have eye motions too. So uh, it, if these were humans, you would think they're dreaming for sure. Now, if they're dreaming, they're not dreaming very long. Their sleep cycle is something like 40 minutes of deep sleep, and then a minute of this active sleep, and then 40 minutes of the deep sleep. Now, it is other animals in the feces in this genetic area that are similar to octopuses, like cuttlefish, also have big brains, and they show these eye movements. And the eye movements are also seen in the sleep of mammals, some lizards, birds, so a lot of other species that have large brains relative to their body weight show this kind of uh, behavior when they're sleeping. And the scientists who are studying this say, quote, I think it's really important to study these sorts of questions in animals like octopuses and cuttlefish because they are a separate example of the evolution of large brains. And so they are telling us something fundamental about what it is to have a large brain and what you need as part of that. So, part of their interest in studying the octopus's sleep cycle is they feel like it helps them understand what's happening with these big complex brains and what do they need. And if we can find patterns that are similar in species that evolutionarily are so wide apart as humans and octopi, then maybe we'll learn something.
Any thoughts?
Well, one of the interesting things about octopuses is they're very good problem solvers in terms of getting out of mazes and opening
Yes.
objects to get food and so on. And yet octopuses are hardwired for this intelligence. They don't learn anything from their parents. When the mother octopus releases all these eggs, she dies, and the eggs hatch and grow up, and the octopus somehow grows up with all this intelligence without the benefit of libraries or language or conversation with adults.
That's
So,
interesting.
yes.
And maybe there's an opportunity here. If they can make money on it, you could have Octopi Wall Street.
That's right. We just have to figure out how to connect the octopus with a brain computer interface.
Yeah.
Any other thoughts?
Well, I would like to see them do a Rubik's Cube.
Well, they have some advantages, yes.
Sure.
Yeah.
Moving on, Richard. Sorry, John.
I don't know how you would give an octopus an IQ test.
Right.
Well, they have 9 brains, sorry.
You have to come up with at least 8 ballpoints.
In terms of us, apparently, I don't know why they made this distinction, but wisdom people have a more diverse microbiome. Lonely people don't. Now, why is that? Anyway, but they don't know which came first, the microbiome or the mental changes. But what's this about more diverse microbiome with wisdom and loneliness?
Well, they have been one of the current areas of human
Research.
science is the evolving science of wisdom. And this science of wisdom rests on the idea that somehow wisdom's traits correspond to distinct regions of the brain. And in studying this, they found that I don't know how in the heck you measure wisdom, by the way, So there's no wisdom meter I know to stick my finger into to get me a wisdom reading like my blood pressure. Uh, they have found, though, that greater wisdom translates into greater happiness and life satisfaction. And when uh, and being less wise results in negative consequences. And they have taken this idea and then done multiple studies that determined that people that they determine are wiser are less prone to feel lonely than, uh, and they have found that people who are lonelier turn out to be less wise. So they found that already in their studying. And what they tried to do here is to try to make some connection between wisdom and loneliness. And they found out one thing that is perhaps really surprising, and that is that the diversity of the microbiome somehow seems to be connected with this wisdom versus loneliness scale, where uh, the more wisdom you have, the more diverse is your microbiome, or they think possibly the more diverse your microbiome is, the more wisdom you have. And the less diverse your microbiome is, then the lonelier you are, or the other way around. They found, by the way, while they're studying microbiomes, uh, that people one condition that shows up with people who have not very diverse microbiomes is depression. So they already have that kind of connection. And, uh, you know, people have talked about this gut feeling, a kind of knowledge that somehow comes from your uh, digestive system. And in fact, they have found real strong connections between your stomach and your brain and the emotional and rational systems of your brain. They still don't understand what's going on, but they know these connections are there. And it looks like this is another place where you see manifestations of this connection. As I say, they still don't know which came first, the diversity of the microbiome or the wisdom or the inverse of both of those, but they definitely see the correlation. And wouldn't it be wonderful if, for example, if you had somebody who was lonely or depressed and you could just give them a pill with their what they need to get a diverse microbiome, and if that pill and the microbiome changes, could change their life. I don't know. This is a part of what we're going to find with this study of the microbiome. I just want to say one other thing about the microbiome before I'm through, and that is its complexity. The human gut microbiome is composed of trillions of microbes. Trillions. That's a big number. We've heard about the bacteria that are a part of it. Viruses are a big part of it. Fungi are a big part of it. And these archaei, which are a microbe that is the order that appears to have been before bacteria and before the cells with a nucleus. Those are in there as well. That's an order of life that we still don't know much about, but may also be affecting our health and behavior. So it's this fantastically complicated thing that we haven't had the tools to even begin to start with until recently with this high speed genetic sequencing that we're doing. And this is an area that we're just starting to discover. And there are lots of surprises.
Any thoughts?
Yes, apparently 90% of the body's serotonin is produced in the gut.
Hey,
I have several friends who are talking about what they consider fact, that we have 3 brains, head, heart, and gut, and the relationship with them is profound. And the other thing I want to say about wisdom, from a Buddhist perspective, might it just be acceptance, or that's too simplistic, Richard?
I don't know how they measure wisdom, so
Yeah.
You can
and
usually measure wisdom by the number of candles on your birthday cake.
Wouldn't that be nice if that were true?
Yeah.
You know, there's one simple thing they could do, a correlation type test, Richard, and that is when people consume large numbers of antibiotics, it kills the gut, the bacteria in your gut.
right.
And they could see whether there's a correlation between wisdom, however they measure it, and the antibiotics that people take.
Oh, that would be a good
Antibiotics
test.
they take,
Then
the more stupid you get. Pardon?
yes, give them the wisdom test, then the antibiotic, and then give them the next wisdom test and see.
Right.
Yes, good idea.
but I thought Richard had an idea that you could take a pill to become wise.
That's right. Why not? Again,
Well,
if the connection goes from the gut to the brain, then improve the gut and we can make the brain better.
yeah, if I tell you what's in the pill, you might not want to take it. It's usually other people's poop.
Well, I
I'm not
know.
kidding you.
Well,
I'm not kidding you.
Tell me more.
he's not kidding. And that's the way they measure people's microbiome is to take this kind of sample and then do genetic works with it. And certainly we've heard about microbiome transplants, and those are poop transplants.
Yeah, but you know what? I did read somewhere that they no longer give it to you in the form of pills because people can't take those pills once they know what's in them. So they inject them, they inject them from the other end.
Okay. I'm not sure that's better.
One of the pills to get wiser though is getting older, because a lot of people, as they get older, they get wiser. They also say that people during the pandemic, older people have dealt with it better than younger people.
That's right, because of the better wisdom of the older people. I wish there were a one-to-one correspondence with getting older and getting wiser, though. I'm not sure.
I think it's having less testosterone. That's why we can handle it better.
Oh, I think that could be it. That's right. You know, because
I just go with my
Impulses.
gut.
I wonder if being a good gambler indicates that a person's got kind of wisdom because they're thinking with their gut all the time.
I always thought that the brain sort of worked like a muscle. The more you use it, or the more need you have for it, the more it develops. And so you know, and the idea that part of your brain's in your gut. I mean, this idea of gut feeling, it's justified. That's true.
And certainly, what we're doing here is we're giving our brains that kind of exercise you're talking about, John.
Right, right. Yeah, for sure.
A lot of wisdom once a week.
And it doesn't require you to eat poop.
Uh, I think to measure wisdom, you fix your tooth, wisdom tooth.
Uh huh.
That's bad.
Anyway,
Moving on to our last question. If we now think that we can get a pill to make us more wise, we apparently now have vaccines that can stop cancer. Richard, what's that about?
This is another story that is, I think, real significant. And, all my life, I've read about them working on a cure for cancer. And what they have found, the more and more we learn about cancer, the more we begin to find characteristics about it that gives us a way that we can figure out how to attack the cancer. And what they have found is there's a kind of mutation that shows up in most cancers, and uh, this mutation is such that your immune system can recognize it and then attack it, and attack the cancer cell and not attack the non-cancer cell. And so they developed then, uh, for test purposes, a brain cancer vaccine. And the vaccine makes the body have a T cell reaction. The T cells are your body's most powerful tool to be able to cure itself and kill uh, what it sees as invaders. And what they have found is the T cells then that are so trained can attack this mutation even though it's kind of deep in the cell's mechanism, so it's not available on the surface of the cell. But the T cells can go after it and kill it and kill the cancer. So what they found, they did initially, this report is about a small test on about 30 brain cancer patients. And out of that 30 brain cancer patients, more than 80% of them, once they were administered this vaccine and they developed the body's T cell reaction based on this, in more than 80%, the cancer either stopped growing or started to shrink. And so these are terrible kinds of cancers for which there may not be a cure, or the cure of brain surgery might be worse than the disease. But here they've created a vaccine that can make the human body attack this kind of cancer. This mutation that is in that brain cancer, by the way, shows up in many other kinds of cancer through the body. And so the experimentalists are going to have a lot more work to do. In the case of this brain cancer, what they have to do is push that through these phase studies that we've heard of for other vaccines. And so if they're serious about it, then in maybe a year, we'll start to see that the brain cancer vaccine is available. And in maybe another year, we'll start to hear that other vaccines for other cancers are available too. So this is a particularly significant development in our fight against one of the diseases that for many people is the most frightening of all, cancer.
Any thoughts?
Well, I was just wondering, I had, well, it's maybe some of you know, I had a wife and she died from brain cancer. Actually, it was a meningioma, which is not really a brain cancer so much as it is a cancer that lives in the lining of the skull, and so it's a benign cancer that only means that it doesn't spread. So, but she did eventually also get colon cancer. So it mutated, if nothing else. At least I think it did, into other parts of her body. And so anyway, I just wonder if you could develop a vaccine, how it can differentiate between the various parts of the brain.
Well, again, it doesn't differentiate between parts of the brain. It differentiates between cells that have this cancer mutation and cells that don't have this cancer mutation. And so it will kill cells that have this cancer mutation, whether they're in the brain or not.
I don't know for sure, but I think that cancer is not a uniform phenomenon. It comes in various forms.
But there are various forms. This particular mutation is one that they find in many forms of the cancer. I don't know how extensive it is or anything else. This is the first article that I've seen on this subject. I suspect there will be more.
Well, it's interesting, certainly.
You know, because the vaccine to stop cancer would be a great product for any of these companies that are making vaccines now.
Yeah. There's a big market for it.
Uh-huh.
Anything else?
Well, I think this was an interesting session. Speaking for myself.
Well, Richard, thanks so much. And thanks to everybody for participating. And we'll see you all next week. Bye
Yes,
for now.
and I'll see you from a new house next week. Assuming the
Ditto.
internet is working.
Okay, happy
Okay.
moving.
See you next week.
Thank you, Richard.
Good to
Fred.
see you, folks.
Good luck with the
Bye-bye.
move.
Okay, thanks.
Take care.
Sign